Hello everyone. In today's session, we're going to see about some knowledge representation concepts of artificial intelligence. Okay, these are the very much important concepts in artificial intelligence. So we'll moving on to the next entire unit. Okay, so this entire unit gives the representation of knowledge, how it works, how machines can interact with human like kind of knowledge, everything. Okay, let's move on to this session. Firstly, the name itself, you can see it's a knowledge representation. So, what's the knowledge will be like? Knowledge will be facts, information, and skills acquired through experience or education. Okay, this is how we call it as knowledge, right? So, there will be some facts and information that is acquired through the experience and or education, right? So, this is how the knowledge is called. And what is knowledge representation? It's nothing but representing the information about the real world in some formal language. Okay, we are just representing the information regarding the real world in some formal language. For example, you are chatting with your friend. Okay, you're chatting with your friend in WhatsApp. So the kind of language you are using, maybe Hindi, maybe English, right? So what does that happen? The data is transformed from you to your friend, and also he may read the text what you have been sent, right? So that is what here knowledge representation, representing the information about the real world in some foreign language. Okay. Similarly, AI also represents the information about the world, so that also communicates in a kind of formal language. Okay, it also enables an intelligent machines to learn from that knowledge and experiences. Okay, so that it can behave intelligently like a human. Why we'll say that the artificial intelligence behave like a human? It's simple, but it behaves like human intelligence. Okay, so it also enables an intelligent machine to learn from that knowledge and experiences, so that it can behave intelligently like a human. Got it? So that we can tell it as a human like intelligence for artificial intelligence. And coming to the diagram, you can see here the sensor will be there, like it's a kind of CCTV camera, right? So the sensing, what does it do? It senses. Okay. After sensing, it stores the entire data. That is what knowledge base. It stores the data, and after that, what does it happen? The decision making will be there. Okay. Similarly, in knowledge representation, you just need to remember what is knowledge. Okay, knowledge is nothing but the facts, information, and skills acquired through experience or education. And knowledge representation is nothing but representing information about the real world in some formal languages. And it also enables an intelligent machine. Okay, what does artificial intelligence do? It enables the machine to learn from that knowledge and experiences, so that it can believe intelligently like a human. So sensing, knowledge base, and decision making. Got it? This is how the knowledge representation of artificial intelligence will be. Okay, now coming to the techniques used for knowledge representation. Okay, the first technique will be propositional logic. The second technique will be first order logic. A third technique will be rule based systems. Fourth technique will be semantic networks. Fifth technique will be frames. And sixth technique will be script. Okay, just take a screenshot of this and we'll move on to deep dive into entire technique, proper explanation and description. Okay, just just understand and remember these kinds of techniques for knowledge representation. Yes, now moving on to the propositional logic. It represents the facts which are neither true or false. Okay, which is either true or false. Okay, the propositional logic is nothing but whether the facts are there, right? So it always represents the facts which are either true or false. Okay, either true or false, but it represents the fact. For example, there are 7 days in a week. That is true. The sun rises from the west. That is false. 3 plus 3 is 7. False. So propositional logic is also called as Boolean logic as it works on 0 and 1. Okay. What does the Boolean means? Boolean means it's whether a true or false only. That is why it is known as Boolean logic. And it either works on 0 and 1. Statements which are questions, commands, or opinions are not propositions, okay, such as how are you, what is your name, where are you from. These are not the propositions, okay. And symbols, ABC, coming to, etc. Connectives like these kind of symbols, okay, they have been used for propositional logic. Make a screenshot and just go through all these concepts 2 minutes. Let me move on to next slide. Yes, you got it right. Propositional logic is nothing but it represents the facts and which are either true or false. Okay, and yes, this is how the propositional logic connectives will be there. The term conjunction, disjunction, negation, conditional, biconditional. I think you already have explored these concepts in mathematics, right? So this is how the propositional logic connectives will be there, similar to artificial intelligence. Like connective symbols, so for conjunction, it's a symbol, and for meaning, it's an and. Okay. For disjunction, you can see the symbol like V, right? And for meaning, you can see or. Negation, that is not. And for conditional, you can see the symbol as arrow, and meaning if then. For biconditional, you can see double arrows, and if and only if, it's a meaning. Just look onto it and understand this table. Yes. Next, moving on to the next one. Translation of English sentence to propositional logic. Just say, Peter can play tennis. That is correct. Peter cannot play tennis. Okay, we are just assuming Peter can play tennis as P. And here you can see the propositional sentence as cannot. So what does it mean? It's a negotiation. Okay. So we are using this negotiation symbol. You can see here negotiation. Negation. Okay. It's used for not. This negation is used for not. Okay. And Peter can play tennis and badminton. What does it mean? And so and symbol we are using. Tennis is P and badminton is named as Q. Peter can play tennis or badminton. You can say or. So or option is there. So it is V. So the symbol will be this. Okay. If Peter play tennis, then he can play badminton. So you can see if then equation is there. If is there and then is there. So we can using single arrow. If the question has if and only if, then we need to use the double arrow. Got it? Just go through this. We will move on to the next thing. So truth table. Now coming to the truth table, as you all know about this truth table and you've gone through during your mathematical way, right? So similarly, you can see here that P, Q, and P and Q. What is the and symbol is? And symbol is nothing but true. It's a kind of multiplication. Okay. What is true into true? That is true. Okay. True into true is true, and true into false, that will be false. Assume always true as 1, false is 0. Okay, you need to assume whenever there is a true, that means it is a binary value is 1, and whenever there will be a false, then the binary value is 0. Then what is here true? 1 into 1 will be 1, so the answer will be true. And here 1 and f is false. What is 1 into 0? It will be false. Okay, it will be 0. 1 into 0 will be 0, then the answer will be 0. And what is 0 into 1? Similarly, it will be 0. What is 0 into 0? 0. And just remember for AND operation, that is for AND operation multiplication symbol. So only 1 into 1 will be 1. That is true into true will be true. Other cases, everything will be false here. And coming to OR operation, this is conjunction, this is disjunction. Okay, you can see here, this is disjunction and this is conjunction. Now coming to conjunction, you can see here true into true will be, that is, this is a kind of plus operator. What is 1 plus 1? You should be the entire answer should be in either 0 or 1. Okay, so either 0 or 1, in the sense 1 into 1 plus 1 will be 1. 1 plus 0 will be also 1. 0 plus 1 also 1. And if 0 plus 0, it will be 0. So it's the opposite of this disjunction. Okay, and coming to the this operator, like single add operator, you can see true into true, like true. Simple way, you just remember for this operation, only T and F will be the false. Okay, that is 1 and 0 will be the 0. Okay, true, false, then it will be false. Remaining all others will be true. Just remember for this implies as a mathematical trick I can give. Max is a tough paper. So that is tough. Max is not a tough. So you can just remember T and F. So tough. So for this implying operation for single arrow, just remember for this tough, it will be false. Every other part will be true. And coming to the implying both sides, you can see which is the you should here, you need to tell whenever two operators like two variables have same sign, then it will be true. If they have different sign, then it will be false. Okay, see here, one, that is true, true. The answer will be true. And here you can see false, false. Same operations are there. Like same variables are there. So the value will be true. If there are different variables, say true, false, and true, false. Different variables, then the option will be false. Coming to negation of P. As I told, negation is the opposite of the word. If there is true, then you will be getting false. And if there is true, you will be getting false. If there is false, you will be getting the true as the answer. This is how the truth table of proposition logic will be there, and also it is useful for many kind of logic truth table. Okay, just to go through all these concepts once again. Now let's move on to the first order predicate logic. This is the first technique, right, of knowledge representation. So coming to the first order predicate logic, that is FOL, first order predicate logic. First order logic is nothing but in proposition logic, we can only represent the facts, which are either true or false. So, example, it is raining. So, it is a fact, right? So, it's either true or false. Okay. So, it is raining, or it will be raining, or it is not raining. That is not a thing, but we need to only represent the fact. But propositional logic is not sufficiently expressive to represent the following statements. Some humans are intelligent. All mangoes are sweet. First order logic is capable of expressing the facts about some or all subjects or objects in the universe. Okay, it is capable of expressing some as a keyword, all as a keyword in the objects in the universe. First order logic specifies objects, relations, and functions, right? The first order logic is also known as predicate logic, and a first order predicate logic that will be syntax. So this is how the syntax will be: function, term 1, term 2, till term n, and we need to predicate that. Again, term 1, term 2, till term n. X is a girl. So X is a subject, girl is a predicate. Here is how the first order predicate logic works. Just go through these concepts once again. Now, coming on to the next thing. Like first order predicate logic, it has quantifiers. That quantifiers will be divided into two things. First one is universal quantifier, and second thing is existential quantifiers. Universal quantifier is it means for all. As I told, first order logic has some keywords like for, all, right? So for that, using that keywords here, you can see quantifiers are divided into two: universal and existential. Universal is for all, existential is for some. Okay, all employees, some employees. This is how the symbol will be. Like a reverse of A and reverse of E. Okay, universal and extension. So take this as a snapshot. It will be useful for your future. Okay, all employees, some students. And coming to the first order predicate logic, constants it will be 1, 2, A, John, Mumbai, cat. The variables will be X, Y, Z, A, B, C. Okay. And predicates will be greater 5, comma 3, student, boy, comma, girl. Why are we predicating two variables inside? We are just comparing those between which is greater, who is boy or girl. Okay. So that is why we are using these two inside. Okay, and see here you can see these two inside. And coming to the function, mother of John. Okay, color of basket. This is how the function works. And coming to connectives, disjunction, conjunction, negation, everything will be there here also similarly. And for first order logic, the equality symbol will be two equal symbols. Okay, and yeah, quantifiers are, as I told, universal quantifier that is for all, and extension cat is for quantifier that is for some people. Okay, some kind of ranges. And coming to the next thing, yeah, this is the first order logic predicate examples. Sam is tall. You can also write tall, which is Sam. John likes cricket. You can also write as likes John, comma cricket. Everyone likes cricket. You you can like for everyone, like that is equals to also all likes x comma that is all comma cricket. And here you can see all students like cricket. So all students, that students like students come a cricket. Some boys are intelligent. So for some boys of X and distribution of intelligent of X, okay, that gives the AND operation. Some integers are even and some are odd. Even and odd. In between them, you will be getting some kind of values like 2 is an even. No, no that. There will be some kind of how to say the values will be there in between odd and even, so you'll be getting that. Not all students like both mathematics and science. This is how it represents, okay? And moving on to the next thing, atomic sentences. Atomic sentences is nothing but it predicates term 1 to term n or term 1 is equals to term 2. Term is nothing but is a function, okay, that goes on term 1 to term n, a constant or variable, okay, this is how it works. Coming to example, brother King King John Richard the Lionheart. So you can say length left king of Richard, length left leg of King John. Okay, this is how the atomic sentences breaks down because there will be one entire word or entire sentence that you need to break down into some kind of particular words that as of first order logic predicates. Okay, so take a snapshot of this, right? So next, moving on to the second one, it is complex sentences. Complex sentences are made from the atomic researchers and philological reasoning. Okay, like that's a kind of connectives. The complex sentences are made from atomic sentences using five logical connectives. Okay, what are the logical connectives? S1 and S2 are the two atomic statements. Okay, S1 will be atomic statement 1, S2 will be atomic statement 2. Then, if not S1, S1 and S2, S1 disjunction S2. Okay, people understand me. So, siblings, King, John, Richard. Another way will be siblings, Richard, kingdom. So, you will be getting the option of this and you are just calculating the entire thing as these values. Okay, just got it right. Yes, you can see here the example of models for FON. Okay, example Richard the Lionheart was the king of England. His younger brother was the evil King John who ruled from 119 like to 1215. The left legs of Richard and John were different, right? And John had a crown because he was king. Okay, this is how it represents. Okay, and the next example will be models of first order logic predicate. Example person, okay, and person, king, crowd, person's brother, okay, left leg, left leg. So the objects are person, king, John, person, Richard, crown, left leg of John, left leg of Richard. These are the main objects. Coming to relationship, on head, the crown, the King John. Brother will be John and Richard. Person is John. Another person will be Richard. King will be John. So this is how it works upon. Coming to function, no other person wears a crown except the king. Right? So John the king on head crown and shoe John the king shoe will be there on the left leg. This is how it works as first order predicate logic. Is a best example. Now coming to prologue programming. It's very useful for artificial intelligence because in artificial intelligence laboratory you might have been using the Prolog programming. So what is this Prolog programming? It's nothing but it's a logical programming language that has important role in artificial intelligence. Unlike many other programming languages, Prolog is intended primarily as a declarative programming language. Okay. In Prolog, logic is expressed as relationship. Yes, right. So in Prolog, what does it happen? The logic is expressed as relationship. That is called as fact and rules prologue. Okay, so three important things in prologue programming will be, when we program in prologue, we need to provide the following three things. First one is declaring some facts about the objects and their relationship, and also defining some kind of objects and their relationship, and asking questions about jobs and their relationship. This is how it works on the Prolog programming language. Query. Coming to query, it's a Prolog database, facts, and rules. Okay, that's a kind of database. It's fully facts, fully filled of facts and rules. Then see here. A query, Prolog database, facts and rules. Prolog programming. Problem solving in Prolog. Okay, insert facts and rules into database. Ask questions based on the context of the database. Facts will be used to represent unchanging information about objects and relationships. Only facts in the Prolog database can be used for problem solving. Insert facts into the um, database by typically involving some facts into the file and loading the file into entirely downwards. Okay, so only facts in the Prolog database can be used for problem solving. There will be some fact, right? That fact will be used for program collaborating. Okay, program solving or program collaboration. Next, moving on to the Prolog programming queries. So it retrieves information from the dataset by entering queries. The query is a pattern that Prolog is asked to match against the database. So coming to this, a query will cause Prolog to look at the database, try to find a match for query pattern, execute the body of the matching head, and will return the answer. This is how it will get returned. Now moving on to the next one, that is English facts. Right? So English prologue. A dog is a mammal. Is a dog mammal? A sparrow is a bird. Is a sparrow, comma, bird. So example, these are the rules and facts that is involved in the artificial intelligence. Coming to rules, something is an animal. So animal will be something X, and is animal X, comma, and mammal. So it is a mammal or a bird. So you can write the prologue programming language as this kind of a animal is a, and some examples in English will be, is a sparrow an animal? Animal speak of the, and another thing will be, is what is a dog? Is dog and some mammal. So you can also take a snapshot of this table so you can get an idea of this. Okay, this is a kind of prologue table, truth table. Okay. Next, moving on to the syntax and basic fields. In prologue, we declare some facts. So these facts constitute the knowledge base of the system. We can query against the knowledge base. We get output as affirmative or a query is already knowledge, right? So base or it is implied by knowledge base. Otherwise, we get output as negative. So knowledge base can be considered similar to database against which we can query. Like prologue facts are expressed in definite pattern and facts contain entities and their relation. So entities are written within the parentheses and separated by comma. Their relationship is expressed at the start and the end of the parenthesis. Even fact and rule ends in a dot. So typical prologue fact also follows as the syntax and basic rules. Okay, so you can get into that before that you can take a screenshot of this. Okay, see an example you can see here. Example friends are Raju and Mahesh. Singer Somu. Odd number 5. Explanation. These facts can be interpreted as Raju and Mahesh are friends. Sonu is a singer. 5 is an ordinary number. This is how it explains every fact and reality. Okay. Query number 1. Singer Sonu. Output will be yes. As your knowledge base contains above facts, so output of yes, otherwise it would be no. So odd number is 7, that is no. Also base does not contain the above facts, so the output was no. For example, English language. Ram likes mango. Ram Seema is a girl. Bill likes Cindy. Rose is red. John owns the gold. Like PL means prologue program. Likes Ram, mango. Girl Seema. Red Rose. Likes Bill, Cindy. And owns John and gold. This is how it works in prologue. Okay. Just take a view of this and we move on to the next session. Unification. What is unification? It's an algorithm for determining the substitutions needed to make two FOL, like predicate FOL practices, and to also apply the rules of inference, and yeah, inference system must be able to determine when two expressions match here the unification algorithms used. The unify algorithm used for unification, which takes two atomic sentences and returns the unifier because it is used for identifying, right? So the unifier identifies the entire thing, okay? And for those two sentences and returns unifier, those it will be taken, okay? Now, did you got what is unification in artificial intelligence? Next, moving on to the next one, unification in project vector. Following are some basic conditions for a unification. Predicate symbols must be same atoms and expressions with notation. Predicate symbols numbers of arguments in both expressions must be identical. Okay, numbers of arguments in both should be identical. Unification will make uh, fail with these two arguments. So unification will fail if there are two similar variables present in the same expression. If there are two similar values present in same and like signification, the unification will fail to be done. Unification. Example: union of MGU for unify kingdom and right. So this one. We can get inference immediately. We can find the substitution theta such that king and PDX match 0 to x comma John y by John works unify alpha comma beta 0. This is how the unification works here. You can take a look over this. And this is also kind of examples. Sum of retrieval. Okay, sum of retrieval. Yeah. Storage and retrieval. Since once the data, the type of sentences and terms are defined, we need to maintain the asset of sentences in KB. To store and feature a sentence or term, stores a sentence, store yes stores a sentence, fetch queues returns all unifiers, such that the query queue can unifies with some content and in the knowledge base. Okay. For example, the unification for nose will be John, comma X. This is an instance of fetching, right? The simplest way to store and fetch is nominating or maintaining your long list in this sequential order. For a query, I have been calling Unify QoS where every student involved in the list. So that requires O of n time on n element KB. To make fetch more effective, indexing the fact is in KB is done. Different types of indexing are as table-based indexing, tree-based indexing, prediction-based indexing. Okay, what is this table-based? For fact employees, the queries are as follows: employees like SSN John, SSN employee John, or X comma John. Okay, these are the examples of this kind of yeah, unification, storage and retrieval. And lastly, you can see here employees x comma y and employees x comma John, employees x comma y to SSN John. So this is a simple diagrammatic representation of this example. I hope you guys have learned much more in today's session regarding knowledge base and its types. So we'll see further information in tomorrow's session. Okay, thank you.